Good morning, everyone. My name is Bailey Brown, and this is going to be the solo teach number 2. So we're going to start off. This is Module 2, Chapter 9 for Math for Teachers 2. So here on question number 1, they're wanting us to find the measurement of all of the angles that are numbered 1 through 12 in red. So before we do this, we need to look at some basic rules of how to find angles. So the first rule is going to be that alternate angles are equal. And as you can see in the image right here, those are alternate angles. And corresponding angles are also equal, which is our second rule. And this is going to be this image right below it. And opposite angles, which is rule number 3, are also equal. And the angles in a triangle should all add up to be 180 degrees. So with knowing this, we can begin finding the angles. So if we add 63 and 61 and subtract that from 180, we will get 56. So we know that the angles in a triangle should all add up to be 180 degrees. So now we've got our angle number 7 because we added these two and subtracted it from 180. So since we know what angle number 7 is, that also gives us angle 12 because of our, which rule is it? Because of the opposite angles being equal, which is rule number 3. With knowing that our opposite angles are equal, we also know that 9 is going to be 61 degrees and 2 is going to be 63 degrees. So our second rule says corresponding angles are equal. So if we see this one right here is 61, its corresponding angle is going to be angle 3. So that one's going to be 61 as well. And this 4 right here is directly across from 3, which is going to make it an opposite angle. So those will be equal to the same. And we see that our angle 7 we found was 56 degrees. So its corresponding angle is going to be angle number 1. So that's going to be 56 degrees also. And because we know that number 1 is 56 degrees, its opposite angle is 5 right here, which is going to make that one 56 degrees. We know that 8 is going to be 124 degrees because these number 8 and 12 should add up to be 180 degrees. So if we subtracted 56 from 180, we would get 124 degrees. And because we know that 8 is 124 degrees, its opposite angle is 11, which is going to make that 124 degrees also. And we're going to repeat this process on the other side to give us 119 for angle 6, and its corresponding angle, its opposite angle is 10, so that's going to be 119 degrees also for this one. Moving on to question 2. It's wanting us to find the angles again of the numbers that are listed 1 through 8 in red. So again, we need to brush up on some basic knowledge before we start trying to figure out these angles. So the first thing is that complementary angles. What are they? They're two angles whose degrees measurements add up to 90 degrees. So as you can see in this example right here, this angle number 1 and this angle number 2 should add up to be 90 degrees. Next thing we need to know is supplementary angles. There are two angles whose degree measurements add up to be 180 degrees. Again, in the image right below here, it's that straight line with a line going through it, and the angle measurements on either side should add up to be 180 degrees. And similar angles, which you can see right here, are two angles of a triangle that are congruent with two angles of another triangle. So if we've got a triangle right here, it's the same measurement, just maybe smaller, or it could be larger. As long as it's the same measurements around, just bigger or smaller, then they're going to be similar angles. We also know that a triangle's angle should add up to be 180 degrees, and a quadrilateral's angles should add up to be 360 degrees. So we start out by knowing that point C, or angle C, is 74 degrees, and angle B is 26 degrees. So with knowing this, we're going to go ahead and go to angle 1, and we know that that's going to be 80 degrees because a triangle's angle should add up to be 180 degrees. So if we add 74 plus 26 and we subtract that from 180, we get 80. So the whole entire triangle is going to be equal to 180 degrees. So knowing this, we will fill in angle 5 because we know that these are complementary angles. And let's see, 74 degrees is going to be angle 6, because if we look up here in this first triangle, the top triangle, triangle C, I'm going to call it, this top angle is going to be 74 degrees, and these are the same triangles, just different proportions, so it's going to be the same degree measurements, which is our rule number 3 of similar angles. So we know that those are going to be the same. And because we know that this bottom point right here of 26 degrees, again, this is the same triangle, same measurement, so it's going to be 26 degrees for angle 4. And these are, corresponding angles. So angle 6 is 74 degrees, so we know that angle 7 is going to be 74 degrees also. Again, with the corresponding angles, we've got angle 5 being 80 degrees, so its corresponding angle is going to be angle 8, which is 80 degrees. And with knowing this, we know that triangle B and triangle C are similar angles, so we know that angle 8 is 80 degrees, so that's going to make angle 3 80 degrees also. And angle 4 right here is 26 degrees, so its complementary angle is going to be angle 2 over here, which is also going to be 26 degrees. And we're going to check our work. The top triangle is 74 degrees plus 80 degrees plus 26 degrees, which gives us 180 degrees. The bottom one is the same because they are similar angles, so we get the same outcome. And the quadrilateral is 26 plus 80 plus 80 plus 74, which gives us 260 degrees. I know I said down here that quadrilateral angles should add up to 360, and this is only if they are regular quadrilaterals. This is an irregular quadrilateral because the sides are not all the same length, so this would be acceptable in this case. Moving on to question 3. They're wanting us to find the measurements of each of these angles. But again, first we need to brush up on some basic knowledge, and we'll start with interior angles. So an interior angle is when one side of the polygon is extended inside of the shape. And as you can see in this image of a pentagon, it shows the interior angles. And then exterior angles are when one side of the polygon is extended outside of the shape. So you can also see right here in this hexagon where it shows the angles that would be on the outside of the shape. So the equation for finding y in this case is going to be n minus 2 times 180 degrees, because this is what the entire thing should add up to be. And we're going to do 8 minus 2 times 180, which is going to give us 1,080 degrees, which is going to be the sum of the entire thing. So what we're going to do first is we're going to add all of these little variables together. So 3y plus 7y plus 7y plus 7y plus 3y plus 12y plus 12y plus 3y we know is going to be equal to 1,080. So all of those numbers added together gives us 54y equals 1080. And what we're going to do next is we're just going to divide 54 from both sides to get the variable by itself. So y is going to equal 20. So your next step is going to be to plug in 20 for y for each of these different sets. So we're going to start off with 3y because it's our smallest. So we know y equals 20. So then we do 3y equals 20 times 3. So 3y is going to equal 60. And then we're going to do 7y next because it's the next smallest number. So we've got y equals 20. 7y equals 20 times 7. And 7y equals 140. And next we're going to do the last set, which is going to be y equals 20. 12y equals 20 times 12, so 12y equals 240. And we're just going to label all of these with the degrees that we got. Question 4 is wanting us to find the angles again. This whole lesson basically is about angles. So with this one, we're going to start with the interior angles, which we have stated just before, which is one side of the polygon is extended inside of the shape. Exterior angles are one side of the polygon is extended outside of the shape. And central angles, which is an angle whose vertex is in the center of the shape. So as you can see, we have an example of each of these in this question. So the equation for getting the interior angle is n minus 2 times 180 degrees divided by n. So the n in this case is going to be 9 because there are 9 sides to the shape. So 9 minus 2 times 180 divided by 9. So we get 7 times 180 divided by 9, which is 1260 divided by 9. And our interior angle is going to be 140 degrees. Next, we move on to the exterior angle. And the equation for this problem is 360 divided by n. Again, n in this problem is going to be 9 because this is the number of sides that the shape has. So 360 divided by 9 is 40. So that's going to be our exterior angle. And then our central angle is the same equation. So it's 360 degrees divided by n. And 360 divided by 9 is 40. So that's going to be the central angle, which I think I've labeled these wrong, but this one right here is the central angle, and this is the exterior angle, but they are equal to the same thing. Question 5. So on this one, they're wanting us to name the face, name all the faces of this cube. So we can start out by doing the top and the bottom face. So if we started, let's go back. We started with, it goes B to A to B, B to F, F to E, E to A. And then same thing down at the bottom. So I'm showing it like this so that way you know which colors, I don't know how to say this, the colors coordinate with being the top and the bottom, the sides, and the back and the front. So the yellow is going to be the top and the bottom. So if we look at what letter is in each corner of the square that we have drawn in yellow, we've got A, E, F, B, and D, H, G, C for the top and the bottom. Next, we'll do the front and the back, which we've done in red. So if we look again at the letters that are in each corner of the squares that we've drawn, we've got A, B, C, D, and E, F, G, H. And lastly, we're going to do the sides, which we did in blue. So we got B, F, G, C, and A, E, H, D. And we can double check ourselves because we know that there are 6 sides to a cube. So we have 3 sets of 2 here. So 2 times 3 is going to be 6, which is 6 sides. And on question 6, it was wanting us to show examples of a tetrahedron, an octahedron, and an isosahedron. So in the tetrahedron, we know that tetra means 4, which is going to mean 4 triangles. And hedron just means shape, basically. So 4 shapes, and in this one we're talking about triangles. So we're going to count them. The whole thing is counted as 1, and we've got a 2, a 3, and a 4. So we've got 4 triangles, so this one checks out. An octahedron, which means 8. So we should have 8 triangles total. So we've got 1 for the whole thing, and then count each of them inside of the shape. So 2, 3, 4, 5, 6, 7, 8. So this one checks out as well. And an isosahedron, and isoso means 20. So there should be 20 triangles inside of this one, well, 19, because there should be 19 inside of it, and the whole thing counts as 1, so it should equal 20 triangles total. So the whole thing is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this one as well checks out. Alrighty, this is all that I have for y'all today. I want to thank you so much for sticking with me and going through this section. See y'all next time.